Balvigyan Bharti with your mentor Avila Sarkar. In this chapter, we'll start from the problem number 25 in the binomial series. And the 25 problem says the coefficients if the coefficients of x square and x cube in the expansion of 3 plus ax whole to the power 9 are the same, then the value of a is how much? So if the coefficient of x square and x cube. So by seeing the expression 3 plus ax whole to the power 9, you will definitely know that power of x in the term will increase from 0 and alternate means 0 consecutively. Each term will increase by 1 only. So whereas x square is has to be present, that has to be there in 2 plus 1 term, because x is increasing according to the value of r plus 1. If I say this is r plus 1, and if the value of r is 0, the x power will be 0. If value of r is equal to 1, then x power is 1, and that definitely will come at 2 to the power n plus, means third term, where the term will carry the coefficients as the highest power n9. C r will be your second, because this is 2 plus 1, where x square I will get, okay, and this is 3 to the power then 7, and along with that a to the power I will get 2, and this is x square. Similarly, x cube I will get at 3 plus 1, that means 9c3, 3 to the power 6 a cube and x cube. Okay, so your task is to find the value of a. Okay, so and what is it is given? The coefficient, not the binomial coefficient. Remember, the coefficient of x square and x cube. So that means we are talking about the whole thing, this and this, the coefficient. Now these are equal to, because coefficient of x square is equal to x cube are same, so we can put this as per the condition. So what are the things? 9c2, 3 to the power 7 a square is equal to 9c3, 3 to the power 6 a cube. Now you can get a one side, so that will definitely be a, and if we equalize, so that will be 9c2, 3 to the power 7, and divided by 9c3, 3 to the power 6. This will be the answer. Now you can further reduce 9c2 and 9c3. How will you get? 9 factorial, 9 factorial 7, 9 factorial, 7 factorial, 2 factorial, and 3 automatically 3 will come at the top in numerator. 9 factorial, 6 factorial, 3 factorial. So you can cancel this, and 3 factorial means 3 will go up, 7 factorial below, and that will be cancelled out with 6 factorial. It will be 7 into 3 again. So this will be 9 by 7. Will be your answer for A. A will be 9 by 7. Okay. So move to the next problem. Problem number 26. If in the expansion x plus 3 whole to the power 16 is the constant term in the expansion. This is the constant term, so that you have to find the constant term, then find it, okay. So you have to find the constant term. So constant term, this you can say word is pointing out towards something. So what is that? This is same as, if it is constant, that means if we expand it, the term I will not get any variable. Constant means that variable x will not be there. So this is similar to where there is x is absent or x power is 0. All are the same expression in a different manner. Here it is constant, that means if I assume that r plus 1th term is the constant term, so this is equal to 16 cr, and as it is constant is already known, so x to the power 16 minus r into 3 to the power r will be how much, where x power means 16 minus r will be 0. So that means r is equal to 16. So it denotes the last term of that is the constant term. So the value of it is equal to 16c16 and 3 to the power 16. This will be your term where x is absent in the term. Okay. Now 27. If NC 3 equal to NC 15, then to find 2NCN is how much? That we have to, sorry, 2N is 20. 20 CN that you have to find. So how will you do that? There is no straightforward. You have to expand it. Factorial n, factorial 3, factorial n minus 3. On the other side, factorial n, factorial 15, n minus 15 factorial. Now you can see that n cannot be equal to 0 because any value below this or this is not possible. Then this have no existence. The maximum power must be, even if you see that there has a maximum power of 15, that also okay, but below the 15 it is not possible in this case. So n is equal to 0 is not possible. So now further, if I expand it I will get something Now this, if I expand, it will be very difficult to calculate. Means if I bring it is from n minus 3 to n minus 14 and then after cancel it out. So I mean to say, let me do this n minus 3 factorial, then only you can understand what I am going to say. And this is equal to factorial 15 by factorial 3. Now how come this will be true? So to understand that, if I expand it, I will expand from n minus 3, then further one reduction n minus 4, like that till n minus 14, because the next one n minus 15 factorial will be cancelled out, and on the other side it will be 15 into 14 plus dot 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 dot. The end term will be 3 factorial will be cancelled 4. Now as this natural numbers when multiplied will give you the same result, and these are also reducing by 1, and number of term here it is from 3 to 14, that means it is 11 terms, and there also this is having the same number of terms, because from 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So there is 12 terms. So from here if you count 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 12 terms. So this number of terms here, this number of terms are same, and both cases each terms is reduced by 1. Here also 15. So can we not say that n minus 3 is equal to 15? Because if we assume this, if we can equalize this, all other terms will maintain the same manner, because if n minus 3 is equal to 15, what is your n then? Your n is equal to 18. Now put this value in each term. N, if you put 18, it will match the next term. If you put n is equal to 18 here, it will match the last term. So consequently all the terms will match if we assume that n minus 3 is equal to 50. So this is your only solution where n is equal to 18 will satisfy the equation. So if it is so, we got from the similarity of the arrangement of the term. So n is equal to, we can find 18. So now we have to find this. So this is equal to 20 factorial into, here it is 18 factorial and 2 factorial. So if we expand it, 20 into 19, then 18 factorial will be there, that will be cancelled with this, and this is equal to 2. So this is 10 into 119 is equal to 190 will be your answer. Okay. The next is 28. C8 plus 10C9 equal to NCR, then the value of mod n minus r plus mod n plus r is equal to how much? You have to find it. Okay. So this is the sum. Now there is no straight method. You have to expand it. 10CR8 plus 10C9 equal to NCR. So 10 factorial divided by 8 factorial, 2 factorial plus 10 factorial and 9 factorial, 1 factorial is equal to, sorry, NCR. I am not expanding this. These are some reason why I am not expanding, because ultimately this will turn into a similar single combination term. Okay. So this I am taking 10 common. From here, if I expand this one, it will be 9 factorial into 8 factorial, 9 that will there. So 8 I can take common, and if it is 2 into 1, 2 will be there. So you can 1 factorial I am taking out. So 1 by 2 will be there, plus 1 by 9 will be there. This is equal to LCR. Or this 9 plus 2, 11. So 11 into 10 factorial, and below will be 9 into 8 factorial, and this will be, you understand what I am doing, 2 plus 1 by 9 will give you 11 by 9 into 2. So that same I am arranging here. 9 I am keeping before 8 factorial, and 2 I am keeping before 1 factorial. So this ultimately the case is equal to NCR. So this is turning into 11 factorial, and this is 9 factorial, and this is 2 factorial, equal to NCR. Now this can be written further as 11C 9 in this manner, NCR. So from there you can understand N is equal to 11 and R is equal to 9. This thing can be understood. Now the next thing that I need to do, N is equal to 9. So we have found already N is equal to 11 and R is equal to 9. So the thing N minus R plus N plus R equal to 11 minus 9 plus 11 plus 9. So that is equal to 2 plus 20, that is equal to 22 is the value. Understood? Okay. Moving to 30, 28 I did, 29. Okay, the sum of coefficients of integral power of x in the binomial expansion is what? The term is given as 1 minus 2 root x whole to the power 50. So how do you find that? Okay, the sum of coefficients of integral power of x in the binomial series. Now one thing is there, the integral power means for this case this could be used for any kind of series where surds or some imaginary number coming into picture, or integral power of those which will make it free from the surds. Actually that will turn into it is a number that is free from surds or imaginary number. That means if you are knowing it that I, the small I represent the imaginary number, the small I value is under root of -1. So under root of -1 you won't get any definite value. This is being signified or symbolic in case any number carries -1 whole root of -1. There is no such relative value will get, so that is being symbolized as small I. So that is in case where the number is carrying the imaginary number of this kind. So there, if you want to free that -1 whole to the power root, so you have to multiply it with a you have to make it as a odd power of that one, means I whole square, if I say the minimum on that which will free it from that root is I square. So I square is equal to -1. So -1 have some existence in the real mathematics. So such you can say the calculation where either surds or the imaginary number can be freed from their you can say the root is called the integral power. So that means the power which can free the imaginary number from the root or the surds which can be free from the surds, okay, from the root itself. So those power are integral. So in this case, any power which is even to x to the power half, means root x means x to the power half, any power which is even to x to the power half or root x is the integral power. So what is the possibility of getting that term where in this expansion is where if I say the first term it is without x, so that is also integral power, means that will give you root x whole to the power 0. So 0 is a specific case where anything can be turned into the constant 1. That also be included in this. Apart from that, all the odd terms, because 1 is where it is odd terms where the power of root x will come the even. Let's say third term, it will give you 2 plus 1 means r plus 1 2. So like that every odd term will give you the free form. So but what is the expansion? If I expand it, this will be c0 where equal to into 1, because that will be free. Then the next term will be minus, and next to that c3 will come, c2, c0, c1, c2. c1 is x to the power, this is equal to 1. c2 will come where 2 to the power 50 minus 2, or straight where you can say first term to the power as first term is 1, I am not looking after this. Only thing is that the power of this will be the case I will get 2 here, that will free it from the power, and at the same time minus, as it is even power, will be eliminated. So I need not to write every term. So this will be like that. If I make it simplify, so c0 will be the case where this will be free from surds. Next c2, 2 square will be x. The next c4, 2 to the power 4 will be the where it will come x square plus dot dot dot. Up to that, what will be, if I see the last term c50, because c50 is also the coefficient with the even. I am looking at the odd terms. The odd terms, the coefficient will carry the even of this number, because c0, c2, c4, then c6, c50 also will be there. The power of 2 will be 50 and x power will be 25, because half to the power 50 means 25. Now what you need you need to the sum of the coefficients of the integral power. So integral power you have already understood what are the things will come in this expansion. I will carry. So this is not the expansion of this. Only thing is the terms carrying integral power, that means any power to the power r, where r equal to even number. Okay, this is the case where I will get the integral power of x. So r will be even. So r will be even except 0, all the odd terms. So this also will be included because it is automatically freeing x. So that means this also can be taken as the integral power where x is free from surds. The my intention is to get x free from surds. So this is also a term which is free from surds. So this also be included. So all in all the even terms, all the odd position terms will be taken as an integral power as, and the rule is this, where root x whole to the power r will be even numbers. So I am taking, this is the summation of odd terms, okay, and odd terms carrying the integral power of x. So this is on. Now want to get the sum of the coefficients. So sum of the coefficients means you have to add only the coefficients. So if you put x is equal to 1, then it will be free from x. That means we are only getting the coefficients, and then the sum, the required sum will be C0, 2 square C2, 2 to the power 4 C4, like that till 2 to the power 50 C15, 50. Okay, so this would be the case. Understood? So to understand the integral power means where it would fit this in case of a imaginary term also. In that case also you have to consider the same, where the even power of such cases will free it from the either surds or imaginary number. That is the only thing. For integral power is that where it would free it from surds or the imaginary number. So this is the case. Now if I expand it, you can see all the odd terms will free it from the surds. So as you can say, the sum of the odd terms which will also carry the positive sign, because this is power of even minus power of even, it will eliminate the negative sign. So this will be very easy to get all the terms being added. At the end, if we consider about the coefficients only, so x value can be considered as 1, then only I can free it from x, and the result will be like that only. Okay. So thank you for now. I will move on to the next problem in the next video, that means problem number 30. Let me write it out so that you should not forget it. So the number I will start from this number 30. Thank you.